Welcome to the Georgia Highlands College Math 97 and Math 99 tutorial videos. In this video segment, we'll be answering the question, how do you factor a trinomial whose leading coefficient is 1? So these are trinomials in the form of x squared plus bx plus c. Now you might be used to seeing an a in front of the x squared term, but since we're going to assume that a is the coefficient 1, it's not showing up there. There's an understood 1 being multiplied with the x squared term. Okay, so to begin factoring this type of trinomial, you want to set yourself up parentheses that give you room to write your factored form in. Then you're going to ask yourself, what are the factors of C that add to make B? When you find those factors, you'll then fill those factors into the form that you created. You have it factored here, and then you'll check with multiplication. So let's take a look at an example. Before we actually get to the example x squared plus 2x minus 15, I want to take a moment to remind you of what these binomials look like when you multiply them together, just so you can see where each part of the factored form is coming from. So we'll just quickly multiply these binomials by distributing each term in the first binomial to each term in the second. So for x plus 3 times x plus 4, we get x squared plus 4x plus 3x plus 12, which when we combine like terms leaves us with x squared plus 7x plus 12. Moving along, multiplying this next binomial by the other binomial, we begin the distribution process as well. And we have x squared minus 4x minus 3x plus 12, which when we combine like terms gives us x squared minus 7x plus 12. So we're just looking at these same binomials just with different signs to hopefully help you understand the pattern that we're going to be using when we factor our example below. So multiplying, we get x squared minus 4x plus 3x minus 12, which gives us x squared minus x minus 12. And finally, when we multiply these last binomials together, we get x squared plus 4x minus 3x minus 12, and combining gives us x squared plus x minus 12. So you see between these four examples here, the only thing that's changing is the value of the center term and the sign of the constant term at the end. So that's all we have changing there. So just with different combinations of signs within the binomials themselves, we yield different results. But you can see, let's take this top one for example. Whatever my constant term is here, in this case positive 12, we have to find factors that multiply to make positive 12, which is 3 and 4, but also add up to make this center term, because when we do our distribution, we end up combining like terms to create that center term. So that's where the second step in this process comes in, asking yourself what factors of c, or the constant term, add to make b, which is the coefficient on the x term. So let's go ahead and move down to our example, x squared plus 2x minus 15. So I know that I can go ahead and set myself up some parentheses that I'll be filling in later on. Because when I multiply binomials, they look like an x in the first part of each binomial that multiplies together to make x squared. And then I have some sign in the center, either plus or minus. And then I have values sitting in the last space there. So I know that when I multiply my x's together, that's what's going to give me that first x squared term, just like it did in all of the examples above. So I just need to figure out what sign I need in the middle and what values I need on the end. So in asking yourself the question, what factors of c add to make b, just to remember the process, I always set myself up something that I call the factoring TP. And I draw what looks kind of like a TP underneath. And that's asking me, what can I multiply back up and make negative 15? However, those same two numbers have to add to make the coefficient of the x term, which is b, and in this case it's 2. So I'm looking for two numbers that multiply to make negative 15 but add to make positive 2. And you can make factor trees however you need to figure out all of the factors of 15, a factor line starting with 1 and 15 and then moving to 3 and 5. But we can see in this case, I need a positive value and a negative value because I need to multiply back up and make negative 15. But I need my positive value to be greater because I need to put them together and come out with positive 2. So those values that I'm looking for in this case are going to be positive 5 and negative 3. So when I multiply positive 5 and negative 3 back up, it gives me negative 15. And when I add them, I get positive 2. So those are the factors that I'm looking for. And from here, the rest is quite simple. You take the factors that you found and simply put them into the form that you created to begin with. So I have a factor of positive 5 and negative 3. So the factored form of x squared plus 2x minus 15 is x plus 5 times x minus 3. Now we should always check that. So we check by simply multiplying these back together just to make sure that we end up with the same polynomial that we began with. So we're going to do that through distribution of each term to each term. X times x gives x squared. X times negative 3 is negative 3x. 5 times x is positive 5x. And 5 times negative 3 is negative 15. Combining like terms, we get x squared plus 2x minus 15, which sure enough is an exact match to the polynomial we began with. So the factored form of this polynomial is x plus 5 times x minus 3. I hope that this has been helpful for you in understanding how to factor trinomials in the form of x squared plus bx plus c, meaning that the leading coefficient is 1. If you have any other questions about this method, please contact your Highlands instructor.